In this video, we're going to learn how to create a template that we can use for creating bosses on plastic parts. Hey everyone, this is Matt with Learn Everything About Design, and in this video, I want to talk about a workflow that we can use to create bosses or any plastic features that we can use and reuse on our plastic part design. Now, the main reason I wanted to make this video is because recently Fusion 360 released a product design extension. And inside there's a boss tool and there's a snap fit tool, and both of these are great tools. However, if you're on a hobby or free license, then you can't access the extensions. So instantly, that takes it out of the realm for you to be able to use that tool. I know a lot of you out there on the hobby or free license are not designing injection molded plastic parts. But I still think the ability to create custom features that we can use and reuse is going to be an important thing. So in the description of the video, I've got a sample file called plastic housing. It's just basically an extrude that's been shelled out. This is just sort of a base that we can use for thinking about how we're going to design a boss. But what I actually want to do is I want to start a completely new design. Inside of the new design, we're going to go in and change our units to inches. You can do the same thing with metric units. It really doesn't matter. But the point of this is we're going to design our own feature, our own boss. We're not going to be using API or creating any code to automate this process, but you certainly could do that. But what we want to focus on is the ability for us to use and reuse components in other designs and tie them back to parameters. So there are two main workflows that I want to talk about. One is creating a new design that you'll then use as a basis for all your future plastic part designs. This is going to be the most robust option, but it's also going to be a little bit more complicated to remember to start your designs in that file every time. The other option is to create what's called a distributed design and then break the link. Now, keeping in mind, if you are on a free license or a hobby license, there is a limitation to the number of active files that you can have at any one time. Now that number is, I think, somewhere around 10 designs, but that does tend to change a little bit over time. So let's just understand and explore the process to make sure we understand it. And if you're making a complex design that has a lot of reused features, then maybe this can help. So the first step in my process, knowing that I'm in the inch unit system, is going to be to go to modify and change parameters. Inside of here, we can define parameters that we can easily access during sketch and feature creation. So I'm going to begin by creating a parameter called thickness. It is important to note that this does affect other areas of Fusion 360. If you are using the product design extension or if you're working in things like sheet metal, there are parameters that get used in the backend. So sometimes the word thickness might not be available. For this example, I'm going to use 0.1 as a thickness value, and this is simply because it's very easy for us to do 60 or 75% for things like internal ribs. So we're going to say OK. We're going to add another parameter, and this is going to be called F thickness, and that's feature thickness. And then I'm going to start to type in T for thickness. I'm going to click on this, and then I'm going to multiply it by that 0.6 or 60%. The value that you use for your internal features is going to depend on the material that you're using, the height of your overall housings, and things like the manufacturer that you're using. But in general, I like to go to the smaller end, at this case 60%, unless I have a good structural reason that I need it to be thicker. Now that I have my thickness of my housing and my feature thickness, I want to add a couple more parameters. So the next one I want to add is called draft. This is going to be an angle value, so we want to make sure that we're not using the units for length. We're going to use the, in this case, angle degree, and we're going to enter the value of 1. Note that when we're adding draft, sometimes this needs to be negative, so we will have to manually add the negative value inside of the features or the dimension dialogues. So now that we have a couple basic parameters, let's go ahead and add one more, and this is going to be my screw size. For the screw size, I'm just going to use a small value of 0.4. And I'm sorry, actually, let's go smaller than that. Let's go 0.08. Let's make a very small plastic screw size. From here, this is going to be all that I really need to help define this boss. While it's not strictly required, I think the best practice is for us to create a new component. And I'm going to simply call this boss. We're going to be creating some copies of this, and if you're following along, then make sure that you do understand the difference between bodies and components. It's going to be very critical for us downstream. So now that we have boss and we have it active, I'm going to get started creating a sketch. Typically, bosses are created by revolving the shape around an axis. It's going to be much quicker than creating a bunch of extrudes, and it allows us to use references as well as parameters very easily. So I'm going to start by creating a vertical line, and I'm going to create a horizontal line. This is going to be the starting point for my revolve. I'm going to hit Escape to get off the line tool. This vertical axis is actually going to be construction, which you can do by hitting X on the keyboard or coming over to your sketch palette. This is going to be the base of this boss. And for this design, I'm going to assume that it is a blind boss and not going all the way through a housing. So from here, I'm going to continue on with my lines, and we're going to create a simple boss, but note the complexity of them can be as much as you want. So we're going to slightly taper this in, we're going to come over, we're going to taper this direction, we're going to come back to the center, and we're going to come down to finish that off. I know it doesn't look like much yet, but just let's stick with it. First, I'm going to use a horizontal constraint on this face because that's going to be horizontal. And then we need to select this perpendicular constraint that got automatically applied and delete it. Now, if we drag this in, you can see that we do have an angle here. Next, we're going to apply some dimensions. First, I want to figure out this draft angle. So from here to this vertical reference line, we're going to start to type in D for draft and then select our draft angle and hit enter. We're going to do the same thing over here. Note that if we hit D here and use the draft angle, it's going to add the 1 degree on the outside as well. So these numbers get placed pretty far away. It doesn't really matter where they are, but sometimes note based on the current design, if you have 10 or 15 degrees and then you add a 1 degree angle, sometimes it'll get placed off the screen. So now that we have our draft angle, the next thing that we're going to do is we're going to come from our center line. This is going to be important. Over to a vertex, not any of these angled lines, but over to this vertex here. We're going to right click and turn this into a diameter. And then we're going to say S for screw size. We're going to hit enter. You can see that this makes it pretty small. Next, I'm going to hit escape to get off my dimension tool, and I'm going to just drag this down to a more appropriate size. When you start sketching, oftentimes it can be hard to really understand the scale of what you're doing. And we're making something that's pretty small. So it can be helpful to take these reference lines that we create and just give them some sort of scale at the start. For example, if I know that this is going to be about 1/4 inch tall, then I can add that from my construction line and I can use it as a reference. Next, let's take this horizontal line, Control or Command select that point and say coincident. This is going to take this horizontal line and place it until it extends all the way up to that vertex. It doesn't matter if it's at an angle or if it's horizontal, it will extend it or move it until it meets that. Then we're going to go to our dimensions. We need to figure out what the thickness of this feature is. And for my purposes, I want this 60% to be at the top. That's going to be the thinnest I want this to go. Any smaller, then it might begin to produce some issues with fill, but it really depends on the housing, the size, or the height of this boss relative to everything else. So I'm simply going to go from one vertex to the other. And I'm going to use F for feature thickness. I'm going to click that and I'm going to say OK. Last, we need to determine how much material is left down here at the bottom of the boss. Generally, if this was attaching to the rest of a housing that was at 0.1 thick, we would want to be careful not to leave too much material here, unless we had some additional ideas about ways in which we can help the plastic flow. We're not going to be getting into theory about plastic part design here, but just note that this thickness is going to be important and we need to account for it. So I'm going to make it fairly small. So I'm simply going to select these two lines and I'm going to say 0.04. Now remember, our thickness of our housing is 0.1. So that 0.04 is going to help us. We're going to say finish sketch. We're going to zoom in a little bit and we're going to create a revolve. The axis is going to be our vertical construction line and we'll say OK. At this point, we're not done. We need to add a bit more and then we're actually going to take some more away. So let's start by creating a new sketch. Again, we're going to go to that top plane and I'm going to create a center point rectangle. And it doesn't really matter what size it is. Let's go ahead and just make it some size that's larger than the boss. Let's finish. Then we want to extrude this. I'm going to extrude it down -T. This is going to be the thickness of my housing. So we join those two together and this represents the thickness of the housing. So now if we were to look at a section view, let's go ahead and do a section view through here. The reason that we're concerned with the hole in the center of the boss is because now we've got this big area of plastic. And what happens here is when this begins to cool, we end up with a sink mark on the outside. So if this was a cosmetic face on the bottom, then this is problematic. So what we would need to do once we get to the final design is we would take this face and we would use press pull and simply continue to bring it down until it's into the housing. So it's going to be a little bit of manual work at the end, but for right now, at least we have this good reference. So let's go ahead to our analysis folder and hide the section view and continue designing these bosses. The next thing I want to do is create another sketch. You can pick either the right or the front plane, either will be fine. We're going to go to Create, Project Include, and Intersect. The selection filter I'm going to set to bodies. I'm going to select everything we have on the screen and say OK. Next, we're going to design a rib. Most of the time, bosses will have structural ribs if they're somewhere in between a housing, or they might have a rib that goes to the outside portion of the housing. Again, we need to be careful with the thickness of the plastic, so we want to be mindful of how big these are. We're going to start by just picking the midpoint of this boss. You can find it when you see the triangle icon. We're going to drag out to the right, and then we're going to come down to the housing, and we're going to add some dimensions. So for me, I'm going to make this section up here fairly small. I'm going to make it half of the feature thickness. So in this case, feature thickness is 0.06, which makes it 0.03. We could do this directly in here by simply hitting F, feature thickness, and dividing it by 2, and that'll work for us. Then we need to figure out the angle of this. Notice that we don't have a vertical reference here. We don't have a horizontal reference, except for the section view of the housing. So we could use this as a reference, but it's always a good idea for us to have some internal references. So I'm going to hit Escape. I'm going to use a construction line, and I'm going to come from here, make sure that this line is vertical, and then I'm going to turn it into construction. Now, when I use my dimension tool, which is also D on the keyboard, I can add an angle between this, and I want to stick this at 45 degrees. Then I need to figure out the height. So from this point down to here, remember that we did use that midpoint constraint, and you can see that it's 0.125. This is going to be automatically over-constraining our sketch, and it's going to convert it to a driven dimension. And that's fine because I'm going to use that value to determine how wide this is going to be. I'm going to do that by selecting this and then hitting Enter. It's going to create a relationship between that driven dimension. So you can see that it's in brackets on the driven dimension, which means that it's based on the overall height of this housing. This can be a great way to add some flexibility to your design because this is going to grow, staying at 45 degrees as the boss or the feature grows. That's assuming that you're using it based on the sketches. Now that we have our sketch, we're going to go into Create and Rib. It is important to note that this tool has been around for a while, but it has received some updates in the product design extension. Now, as it stands today, if you have the product design extension, you can use this to add draft as well as a fillet to the rib that you're adding. If you're on a hobbyist license, you're not going to see those features. You're only going to have the standard rib tool that we've had for pretty much ever. So I'm going to create this based on the fact that we're not going to be applying draft here, and we're going to do it after the fact because that's what most of you on the hobby license are going to do. From here, we need to select a pull direction if you do have the product design extension. Again, it's not going to matter for us because I'm going to use 0 for draft and 0 for fillet. Then we need to determine the thickness. This is where we're going to hit F for feature thickness, and you can see that it automatically creates this for us. Now that we have this, let's go to Modify, Draft. Our pull direction is going to be this flat face or the plane that's based on the bottom of the boss. And the faces will be the 2 rib faces that are going to be perpendicular currently to the pull direction. Again, the draft is going to be based on that parameter that we created, D for draft, which is 1 degree, and then we're going to say OK. Now that we've added this, let's go ahead and go to Create, Pattern, and create a circular pattern. There are a couple different ways that we can do this. You can do it based on the feature, which would be the rib and the draft, or we can select faces. Then we just simply need to select the faces that we want. Also note, if you are keeping your view like this, and you want to select the face that's hidden, we can simply hold down the left mouse button and it'll bring up this selection dialog. You just simply need to move the cursor around until you get to the face you want. Next, the axis is going to be based on the boss itself, and the number of instances I'm going to set to 4 for right now. Now we've created an entire boss, but we're not quite done. I'm going to go to Split Body. I'm going to split this entire body. The tool is going to be this top plane, and this is important because our boss was built off of the plane up, and then the thickness or the extrusion on the bottom was built down. So we can very easily just use that plane as our splitting tool. Then we can go into our boss component, into the bodies, find the base body, right-click, and remove it. Remove is critical because it's going to place a feature in the timeline for us, and it's not going to break any of the work that we've already done. The last thing that I want to add to this is go to Modify, Chamfer, and I'm going to add a very slight chamfer to the very top edge. This is typically done to remove the hoop stress when you're using a thread forming or thread cutting screw in plastic housings. Oftentimes, if you're designing thin plastic parts, the stress from just inserting that screw and starting to thread will cause a crack in your boss. So putting a small chamfer there can really help that. Now that we have everything designed, let's make a couple different versions of this. So I'm going to go back to the top of my design. I'm going to select the entire boss component. I'm going to right-click and select Copy. Note that you can also use Command-C or Control-C on a PC. Then I want to right-click and note that inside of here, we've got Paste. But Paste is going to create an exact copy, and if we modify one, it's going to modify the other. So what we actually want to do is go to the very top level and find Paste New. Paste New is going to be the critical step in this process because it's going to create a new version that is independent. We're going to just simply move it off to the side and capture its position. Then we're going to repeat this one more time. Again, Paste New. This time I'll drag it off to the left, capture its position, and say OK. Now we have 3 identical bosses, but let's make some different configurations of this. I'm going to activate the second one. Notice that I have all of the features that were used to create it. So in this instance, I'm going to right-click and edit the feature for our pattern. I'm going to change it to 3 instances and say OK. Then I'm going to activate the top level. Notice that the original has 4, and this one has 3. The only reason it snapped to the center was because we used that capture position when we created our copy. Next, let's activate the last one. In this case, I don't actually want to have any different ribs applied to this boss. Sometimes you just don't need a rib or you need to attach it some other way. So I'm going to go to that feature. I'm going to leave it in here, but I'm going to suppress it. Then I want to go to Draft, suppress that, and the rib, and suppress that as well. Then back at the very top level, you can see I now have 3 different bosses. You're probably thinking, great, I have 3 different bosses, but what can I do with them? Well, the benefit of this is now we can create a saved document that is the basis for our plastic parts. If you spent a lot of time creating the other side of these bosses so that you had the good intersection, then what we could do is we could simply create this as the basis, and we could go to Modify, change parameters, and if we have a different thickness value, we know that we based everything off of those thicknesses. So let's go ahead and minimize this a little bit. And let's say that our housing thickness actually needed to be 0.08. We say OK, and it's going to update everything, the thickness of the boss, the thickness of the ribs, but you will notice that we might see some potential issues. You can see here that this portion is going up. So that means that back in the original sketch that was used to create that rib, we need to make sure that we account for that. So I'm going to go back to that sketch. I'm going to edit this, and notice that this line is based on a height value here, and it's not based on a horizontal relationship. So this is why it's important that we make sure that we sketch and we place these dimensions and constraints extremely carefully. So think about this when you're designing your own, and if you want to make those changes, you obviously can. I'm not going to go back and fix anything. Just note that there are some nuances to the way in which we create these. I would suggest, if you plan to do this for yourself, that you create one and you change some of those values to see how it updates, and then from there, you can create your copies. Remember that using Paste New breaks the link between the original. What I want to do is I'm going to rename these Boss 3 Rib. I'm going to call this one Boss No Rib. And I'm going to call this first one Boss 4 Rib. So again, it just kind of reminds me what they are. So again, what I would say, or what I would suggest is probably best practice, is to have this as the basis or the template to start your designs So that way you can design in any features and you can drag and drop them and apply them to your designs. But what if you want to use this as a template to bring into a current design? So let's talk about that. First, we need to save this design. And I'm just going to call this bosses for now. And I'm going to go into our plastic housing design. I should note that this housing does not have draft. It's not in any way manufacturable, but it's just going to be the basis for applying these tools. Note also that this was designed as a body and not a component. It's not really going to matter, but again, best practice is that we should create a component first, and then we can activate it when we want to work on it. We can always convert these to components at any point in time, but I want to show that this works on bodies and components despite what you have in your workflow. So let's expand our data panel, and I'm going to go to the file bosses, and I'm going to just simply drag and drop it. When I do that, I'm just going to pull it up and out of the way, and I'm going to say OK. I'm going to minimize my data panel, and now note that I have this component that's been added. If you want to create some consistency or some standards, then you can maintain a link between certain features. However, I find in most cases that if you're going to use this workflow, you should break the link. So we're going to right-click and select Break Link. From here, we now have our component, which contains all of our bosses. So this means that we now have a body inside of each of these that we can copy and we can use whenever we need it in our housing. So if we want to apply one of these to a body, the first thing we need to do is figure out where it's going to be located. We can manually drag it around, but that's not very precise. So I'm going to start a sketch inside of the inside face of my housing. I'm going to go to Create, and I'm going to pick a point to figure out where to put this. So obviously we could place it right at the origin, but what if it's somewhere out here in the housing? I'm going to use D on the keyboard to just add a couple dimensions. We'll say 0.6, and I'm going to give it a vertical dimension of 1/8 inch. Now what we can do is figure out which boss we want to use. In this case, let's grab the boss 4 rib. I'm going to expand it, go to bodies. I'm going to select the body, and I'm going to copy it. So we're going to go to copy, and now we're going to go to paste. We don't have to do paste new because we're selecting the body and not the component. But I am going to go back up to the top of the housing, right click, and use paste here. I'm going to just drag it off into space so we can see how we can actually position this. But note that there is an option to go point to point directly from here. I find that using point to point on the move copy can be very handy, but understanding how to do it manually is also important. So from modify, we could use move copy again, but I find that align is a pretty handy tool and it has a little bit more flexibility. So I'm going to select align. Note that we are using the bodies option, and then we're going to select the from and to positions. This is important. When we hover over a face, it gives us a lot of different selection points. And we need to pay close attention to the orientation of the graphic on the screen. We want to make sure that the plane that we're selecting or referencing is going to match the plane where we want to put this. So if you're hovering over a face, align will let you click any point, but it's important that we do pick the center. Next, as we rotate, we're going to pick the position we want to place it. And again, pay close attention to the icon. Once we say OK, notice it's placed directly there. Also note that we have an angle option, which allows us to change the orientation, but in this case, there is really no other position that this could be in. If you decide that you need to rotate this to another angle, then we can come in and use Move Copy, and then we can use the Bodies option, and we can simply rotate it until it's at the appropriate orientation. In this case, 45 degrees might work, and we'll say OK. Next, we would use Combine, and we would select our target body as the housing, and the tool body as the boss. Now we've combined those two together, and inside of the top level of our design, we have a single body. Remember that we can use tools like Press Pull. We can select the inside, and then we can drag this down so that we don't have that thick region in the bottom. There are some problems doing this on tapered faces because you can see that it can extend all the way through the housing. But we can pull it down, and it's helpful to have a section view at that point in time. So now let's repeat the process with this boss. So this is the one with no ribs. We're going to expand it. We're going to select that, and we can either use copy and paste, or we can do move copy and use the create copy option. With this, I'm going to say point to point. I'm going to select the bottom point on my housing on the boss and the point on the housing. If the orientation of the boss is already correct, then it'll just work. However, if the orientation is not correct, then you'll find that Move Copy doesn't give you the best results and that Align is probably going to be a better option. Because Align is actually taking into account the face you selected and the orientation of that graphic. So we're going to use Create Copy, and now we've moved it. In this case, I don't really need to see the sketch anymore, and I want to use Combine one more time. Combine those two together, and once again, we've added that boss. So you can see that this can be extremely handy if we have the boss pair. If we have the other side of this, for example, we can move them both together, place them in the housing, and then adjust them. But now you might be thinking, well, that's great, but what if we design this to be the wrong size? Well, that's where tools like Press Pull come in handy. If we select the chamfer and the top face here and we pull this up, you'll notice that we can change the height. And because we are dealing with draft, it will stay. You can see that the whole size is actually shrinking and growing as we move. So it's going to take into account the draft of the inside and outside faces and allow us to reposition that. We can also use Move Copy. We can select the faces option, and we can select the inside, the outside, the chamfer, and the top. And we can actually move this entire thing. Even though it's already combined, we can reposition it on the housing. So there's a lot of flexibility, especially if your design isn't completely nailed down, where you can use these tools to do some direct editing and direct modeling and simply resize them as needed. There are some limitations to that, and you want to be careful when you use things like Press Pull to try to resize the wall thickness of the boss. It can be done, but you want to make sure that you have precise input on that. Again, this would work if this was a component, but make sure that when you're using Move Copy or Align, that you are copying the body and not the entire component. Because this is components, they can freely move about in space. After your design is done, remember that copying those bodies will allow you to simply take this, right-click, and remove the entire group of components. So you only need to keep it around as long as you're designing, and once you're done, you can remove it and you'll have that in your timeline. At this point in time, that's going to be as far as I'm going to take this, but just note that there's a lot of flexibility that you can have in designing these parts from the start. Then you can reapply them and use some direct modeling tools like Press Pull, Move Copy, and even Delete to help create your plastic designs. If you have any questions on this process or you get stuck along the way, please leave a comment or send me an email, support@caducator.com. Thanks for watching, and we'll see you in the next one.